Hello all. The objective of this video is to determine the characteristics of an LTI system from the impulse response. That is, suppose I know the impulse response of the system, then what characteristics can I determine about the system by observing the impulse response? Okay, now let us consider a discrete time LTI system, that is linear and time invariant system, whose input is given by x of n and output is y of n, and the impulse response of the system is represented by h of n. Then an equation which relates all these three terms is given by the convolution sum, which is written here. Y of n is equal to summation k is equal to minus infinity to plus infinity h of k into x of n minus k. Now in the next line, I have expanded the equation by substituting different values of k, that is k is equal to minus 2, minus 1, 0, 1, 2 and so on. Now if I substitute, for example, if I substitute k is equal to minus 2, I get h of minus 2 into x of n plus 2 from the above equation. Similarly, if I substitute k is equal to 1, I get h of 1 into x of n minus 1 and so on. So now, having the relationship between the input, output and the impulse response of a discrete time systems, what can I deduce? So the objective is, by observing the impulse response, when can I say the system is static? That is, when can I say the system is memoryless? Okay, now before that, let us try to recollect when can we say the system is static by knowing the relationship between an input and output of a system. Now, a system is said to be static or memoryless when the output is dependent only at the current instance of the input. That is, suppose I am interested in determining the output y of n at n is equal to 0, then that output should depend on the input only at n is equal to 0 and so on. Okay, so now let us go back to this equation. Say as per that definition, then I have y of n is equal to h of minus 2 into x of n plus 2 and so on up to h of 2 into x of n minus 2. It continues like that. If that is the case, now suppose I am interested in determining the output at n is equal to 0. N is equal to 0. Now if I substitute n is equal to 0 in this equation, then I get h of minus 2 into x of 2. X of 2 is nothing but it is depending on the future values. H of minus 1 into x of 1, again a future value x of 1. H of 0 into x of 0. Okay, output is dependent only on the current instant of time. And let us continue. N is equal to 0, h of 1 into x of minus 1, past value. H of 2 into x of minus 2, again a past value of the input. So from this I can infer that these terms, h of minus 2 into x of n plus 2, h of minus 1 into x of n plus 1, the one which is in red, and h of 1 into x of n minus 1, h of 2 into x of n minus 2, these terms should not be there. In other words, the coefficients, that is the impulse response coefficients, that is h of minus 2, h of minus 1, h of 1 and h of 2 should be equal to 0. So that is only h of 0 should be present. H of only 0 should be present, but whereas all other terms, only this term should be there, and whereas all other terms, h of 1, h of 1, h of 2 and h of minus 1 and then h of minus 2, all these terms and so on, all these terms should be equal to 0. Only then y of n will be in the form of h of 0 into x of n. Only then the output will be dependent on the current value of the input. H of 0 may be any constant, say c. So y of n will be in the form of c into x of n. So what am I trying to tell? H of n should be equal to, only this value should be present, only at n is equal to 0 it should be present, at n is equal to 0 it should be present, and for n not equal to 0 it should be equal to 0, and at n is equal to 0 it can have any value which is c. This is nothing but the definition of an impulse function. So if I elaborate it, if I take the c outside and if I write it, it is equal to 1 at n is equal to 0, and it is equal to 0 for n not equal to 0. So if h of n, if the impulse response of the system is of the form c into delta of n, then I can say that the system is static. If the impulse response of the system is of any other form other than this, then the system is said to have memory. Let us try to determine when can we say that the system is said to be the causal. So next we are trying to determine when is the system is said to be causal. But before that, let us try to recollect from the input-output relationship, when can we say the system is causal. If the output is dependent on the current or the past value, then the system is said to be causal. Okay, the system is said to be causal. But if it is dependent on the future value, then the system is said to be non-causal. So now the output should depend on only current or only past or combination of any of the things. So if I go back to the previous term, if that is the case, again I'll substitute in this equation n is equal to 0. If that is the case, y of 0 is equal to, in the same, following the same thing, it will be h of minus 2 into x of 2 future value, h of minus 1 into x of 1 again a future value. So what I am trying to say is these terms should not be there. That means what? H of minus 2 should not be there, h of minus 1 should not be there. Let us continue. Y of at n is equal to 0, h of 0 and x of 0. Okay, the output is depending on the current value of the input, so it can be there. H of 1 into x of minus 1, yes, it can be there, it is past value. H of 2 into x of minus 2, again a past value. So all these terms can be there. H of 1, h of 2, h of 3 and so on can be there, including h of 0, but not h of minus 2 and h of minus 1. So what I am trying to say, if the system is said to be causal, then from that equation, h of minus 2, h of minus 1, h of minus 3, everything should be equal to 0. What about the other terms, that is h of 0, h of 1 and h of 2 and so on? They need not be equal to 0. These terms can be there, but whereas this has to be compulsory be present. In other words, if the impulse response h of n is equal to 0 for n less than 0, then the system is said to be causal. Now, whatever the conditions that we have derived for a discrete time system, the same condition also holds good for a continuous time system. That is, if h of t is of the form c into delta of t, then the system is said to be, the continuous time system is said to be static by observing the impulse response. Again, if the impulse response of a continuous time system is equal to 0 for t less than 0, the system is said to be causal. Okay, fine. We will see about the other properties, when can we say the system is stable and invertible, in the upcoming videos. Thank you.